Friends, welcome back to this new session. In this session, I am starting with the problems on binomial and Poisson distribution problems. Okay, these problems have appeared in the previous year question papers. Here is the first problem. The probability that a pen manufactured by a factory is defective is 1 by 10. Okay, the probability that the pen is defective is 1 by 10. If 12 such pens are manufactured, what is the probability that exactly 2 are defective? So you have to find the probability that exactly 2 of them are defective. Second is at least two are defective. Okay, at least two are defective. And third one, none of them are defective. So let's see how to solve them. Okay, since the number of the pens manufactured is 12, okay, and the probability of the pen to be defective, I'll take it as P. Okay, so probability of, so let us consider the probability of a pen defective. I'll take it as P. Okay, P as 1 by 10 or it is 0.1. Okay, we'll take it like this. Next, if P is 1 by 10 or 0.1, the probability of a pen not to be defective, that is Q, it will be 1 minus P, which will be 1 minus 0.1, which is 0.9. The probability that the pen is not defective will be 0.9. So by binomial distributions, yes or no? By binomial distribution, we have the probability distribution function P of x as NCx P raised to x Q raised to n minus x. So you will have, there are 12, n is equal to 12 here. Okay, so it will be 12cx, P raised to x means it will be 0.1 raised to x, and Q raised to n minus x, it will be 0.9 raised to 12 minus x. It's very simple, very easy problem. Okay, if 12 pens such taken at a time, 12 such pens are manufactured, means you are going to consider n is equal to 12. Everything is ready with you now. Okay, let's start directly. Exactly 2 are defective. Exactly 2 are defective means, see, probability of x, okay, x successes out of n trials, it is like this. Means for x is equal to 2, we have to evaluate, okay, with these numbers. Okay, so first one, probability of x is equal to 2 we are finding. Exactly 2 means probability of x equal to 2. So it will be NC2. Okay, so NC2 means it will be 12C2. Okay, 12C2 0.1 raised to 2 into 0.9 raised to 12 minus 2. You will get it like this. Okay, now when you further simplify this, okay, if you further simplify this using your calci, it will be 12 into 11 divided by 2 into 1 into 0.1 square into 0.9 to the power 10 you will get. Okay, substitute all the values in your calci. This is 6. Okay, 66 into 0.1 whole square into 0.9 to the power 10. Just evaluate it. It comes out to be 0.2301. Okay, this is the probability of getting exactly 2 defective. Okay, next is probability of at least 2 defective. At least 2 defective means 2 or more than 2 are defective. The meaning is 2 or more than 2 of them are defective. Okay, so you have to work for, it's a large expression. Instead of that, we can go for other part as well. So probability that, second one is at least 2 are defective we have to work for. At least 2 defective means, let me write it, at least 2 are defective. What do you mean by at least 2 are defective? 2 or more than 2 are defective means you are going to work for P of x is equal to 2 plus P of x is equal to 3. Okay, and it continues plus so on till plus P of x is equal to 12. Okay, all this we have to work for. Okay, so but you know that probability, sum of all the probabilities is equal to 1. The probability is distributed, it is equal to 1. So we can easily evaluate it by, so the probability of x, we can say that x greater than or equal to 2. Probability at least 2 are defective in mathematical term, I can write probability of P x greater than or equal to 2. At least 2 are defective means 2 or more than 2 are defective. Right from 2 to 3, 4 up till 12. I can write mathematically it like this. Okay, so since the probability added throughout it will be 1, so I can easily solve it as 1 minus P of x is equal to 0 minus P of x is equal to 1. Right from 2 it is there, addition of all this, if I again add p of x is equal to 0 plus p of x is equal to 1, the sum of that it will be equal to 1. So I want the sum of all these. So I can easily get it by 1 minus p of x is equal to 0 minus p of x is equal to 1. So let's solve this. So p of x is equal to 0. X is equal to 0, we'll substitute the value. We have got p of x over here. Okay, so let me mark it with a different pen. We have got our main p of x over here. So for different values of x, we have to substitute it. Okay, so keep that in mind. Okay, so for x is equal to 0, it will be 12c0, 0.1 raised to 0, 0.9 raised to 12 minus 0, which is 12, minus p of x is equal to 1, it will be 12c1, 0.1 raised to 1, 0.9 raised to 12 minus 1, which is 11. Okay, now use your calci to verify all, to simplify this expression. Okay, if you simplify this, it will be 1 minus 12c0 is 1, 0.1 raised to 0 is also 1, so it will be 0.9 to the power 12. Use your calci to find out this big number. It's point something. Okay, and then 12c1 is 12 into 0.1 into 0.9 to the power 11. So use your calci to evaluate it. It comes out to be 0.341. Okay, so you should be getting the probability of at least 2 defective as 0.341. So first answer is this, the second value, the second which we have evaluated is this. Okay, next one. Okay, the last one that we have to evaluate is none of them are defective, means p of x is equal to 0. That itself we have to work for. Okay, none of them defective, none of them defective. Or if they ask you p of 8, 8 pens are defective, 4 pens are defective, at least 4 pens are defective. So you are just going to construct your binomial distribution function p of x. Okay, and then because it's a binomial, you see, pen to be defective and not to be defective, there are only 2 possibilities. So therefore and the number n is also very small, that is n is equal to 12. So it's very clear that this problem is based on binomial distribution. This is how you're going to verify it. If n is very large, like 1000, 2000s, that time we go for Poisson distribution. That time I'll let you know which problem you have to consider it as a Poisson distribution. When the value of n is very small, like 10, 12, 20 and all that, that will be for binomial distribution. Always remember that. Okay, now none of them are defective will work for yes, none of them are defective. None of them defective means p of x is equal to 0. None of the pen is defective. So we have considered p as the probability of defective pen. So p of x equal to 0 means it will be, we have already evaluated it, 12c0, 0.1 raised to 0 and 0.9 to the power 12 minus 0, which is 12. So it will be 0.9 to the power 12 and its value is 0.2824. Evaluate in your calci. So this is the final answer for your last term. Okay, last question, that is none of them are defective. I hope you have understood this problem. Let's continue with one more problem which has appeared in the question paper. Here is one more problem for you. The consignment of electric lamps, 5% in the consignment of an electric lamps, 5% are defective. If the random sample of 8 lamps are inspected, okay, what is the probability that one or more lamps are defective? One or more lamps are defective, you have to work for. Okay, so first of all, read the question properly. The probability of defective lamp, will take it as P. Okay, so first of all, there are 8 lamps, they are inspected at a random, so we can consider n is equal to 8. Okay, the probability, let the probability of defective lamp, probability of defective lamp be P, and it is given to be 5%. Okay, so therefore P is equal to what? 5 divided by 100, which is 0.05. If P is equal to 0.05, you can directly write Q. Q is 1 minus P, which is 1 minus 0.05, or which is 0.95. You will get Q as 0.95. Okay, now we'll construct the P of x for this particular problem with these values. P of x, for it is but the binomial distribution once again, because n is equal to 8. So NCX p raised to x, q raised to n minus x. So let us substitute all the values here. So what do you get? So you get ncx, n is 8, 8cx, p is 0.05 raised to x, q is 0.95 raised to 8 minus x. So this is the probability function for this problem. Okay, now probability that we have to evaluate probability p of one or more lamps defective we have to work for, is it? So it is actually equal to p of x is equal to 1 plus p of x is equal to 2 plus so on to p of x is equal to 8 up till 8. One or more of them are defective we have to find. Okay, so it is as good as writing 1 minus p of 0. P of x is equal to 0, because addition of all these, if I just add p of x is equal to 0 over here, it will be equal to 1. So probability is distributed should always be equal to 1. Again, I don't have to find each of the probabilities and add them. We can just go for one simple expression, that is 1 minus p of x is equal to 0. So it will be equal to what? 1 minus p of x is equal to 0, or 1 minus, just write here the value of x as 0. So 8c0, 0.05 raised to 0, 0.95 raised to 8 minus 0, which is 8. Okay, so it is 1 minus, this is 8c0, which is 1, 0.05 raised to 0, it is also equal to 1, 0.95 raised to 8 you have to work for. So 0.95 raised to 8. If you just solve this in your calci, the answer will come out to be 0.3366. Okay, I hope the point is clear to all of you. This is the final answer. The probability that one or more pens are defective is this. I hope the point is clear. We'll continue with one more problem here now.